In 1905, Albert Einstein published a paper containing an equation that appears in every physics textbook. The equation itself is simple. What it describes is not. Most explanations you will hear about this result are incomplete. They focus on what Einstein discovered, but they skip over why his method worked when others failed. This video will explain the mechanism that made Einstein's approach different. That explanation will not come immediately. First, we need to understand what everyone else was doing wrong. In 1905, Einstein was not trying to unify mass and energy. He was trying to resolve a contradiction in electromagnetic theory. Maxwell's equations described how light propagates through space. These equations predicted that light travels at a constant speed, but they did not specify what that speed was measured relative to. Classical physics assumed there must be a medium called the ether through which light moved. Experiments had failed to detect this ether. Einstein recognized that if light always travels at the same speed regardless of the observer's motion, then our concepts of time and space must be wrong. This was not a minor adjustment. It meant that simultaneity, the idea that two events happen at the same time, was not absolute. It meant that moving clocks run slow and moving objects contract. These conclusions were not metaphorical. They were mathematical requirements. Einstein built a new framework called special relativity. Within this framework, time and space were not separate. They formed a four-dimensional structure. Mass and energy were not separate either. But the connection between them was not obvious from the theory itself. It emerged from a specific calculation. The most common misunderstanding is that Einstein simply noticed that mass and energy are equivalent and wrote down an equation. This is incorrect. The equation was a derived result, not an assumption. Another explanation claims that Einstein used pure thought experiments about light and motion to deduce the relationship. This is partially true but incomplete. Thought experiments guided his reasoning, but the actual derivation required mathematical analysis of upward needle rate first, that elke recting needle of a loidros per rate fout per dat bandidus, all returning nymph meet. A third version suggests that Einstein discovered this by studying radioactive decay or nuclear reactions. This is chronologically backward. The equation was derived in 1905. Nuclear binding energy was not measured until decades later. The equation predicted those measurements. It was not based on them. Some sources claim the equation applies only to objects moving at the speed of light. This is false. The relationship between mass and energy is universal. Others state that mass turns into energy in nuclear reactions. This phrasing is imprecise. Mass does not disappear. The total energy, including mass, is conserved. What changes is how much of that energy is in the form of rest mass versus kinetic energy or radiation. These errors persist because the actual derivation is rarely shown outside of advanced physics courses. Einstein's derivation appeared in a short paper published in September 1905, several months after his main relativity paper. The title was, "Does the inertia of a body depend upon its energy content?" The setup was simple. Consider an object at rest that emits two pulses of light in opposite directions. The object remains at rest because the light carries equal momentum in both directions. Now analyze the same process from the perspective of an observer moving relative to the object. In this frame, the light pulses have different energies due to the Doppler effect, but the object's velocity does not change. The kinetic energy before and after emission must be the same. Here is where the mechanism appears. In classical physics, kinetic energy depends only on velocity. If velocity does not change, kinetic energy does not change. But in this scenario, the object has lost energy by emitting light. The kinetic energy formula must be wrong, or something else must carry energy. Einstein showed that the object's mass must decrease. The energy lost as light must equal a decrease in the object's rest mass. The relationship between the energy lost and the mass lost is determined by requiring that energy and momentum are conserved in all reference frames. The speed of light squared appears because it is the conversion factor needed to make the units consistent, and the conservation laws hold under Lorentz transformations. The derivation does not rely on nuclear physics. It does not rely on particle collisions. It relies only on the Doppler shift of light and the requirement that conservation laws work the same way for all observers. The constant c squared emerges from the mathematical structure of spacetime, not from empirical observation of matter. This is why the equation is exact. It is not a fitted parameter. It is a geometric consequence of how space and time relate to each other. The full equation is often written as E equals mc squared, but this is the rest energy. A moving object has additional kinetic energy. The complete relation is E squared equals P squared C squared plus M squared C to the fourth, where P is momentum. When momentum is zero, this reduces to the familiar form. The equation does not say mass turns into energy. It says mass is a measure of rest energy. These are different statements. The immediate consequence was theoretical. Einstein had shown that mass is not a separate conserved quantity. Only energy and momentum are independently conserved. This unified two concepts that had been treated as distinct. In 1932, John Cockcroft and Ernest Walton measured the energy released when lithium nuclei were split by protons. The energy matched Einstein's prediction based on the mass difference before and after. This was the first direct experimental confirmation. Nuclear reactors and weapons rely on the conversion of a small amount of rest mass into kinetic energy and radiation. The sun's energy output comes from fusion reactions where hydrogen nuclei combine into helium. The mass of the helium nucleus is slightly less than the mass of the hydrogen nuclei. That missing mass appears as light and heat. Particle accelerators create new particles by converting kinetic energy into rest mass. An electron and positron can annihilate, producing photons. Two photons can collide and produce an electron-positron pair. These processes are reversible and exact. The equation also explains why nothing with mass can reach the speed of light. As velocity increases, kinetic energy increases without limit, requiring infinite energy to reach light speed. Most educational materials present the equation as a fact without derivation. Students memorize it without understanding where it comes from. This creates the impression that Einstein guessed the relationship or discovered it experimentally. Neither is true. The equation is taught in introductory courses, but the derivation requires special relativity, which is often delayed until advanced courses. This gap causes confusion. Popular science emphasizes the equation's applications, nuclear energy and particle physics, but ignores the logical structure that makes it true. The result is that even people who know the equation do not know why the speed of light appears in it, or why the exponent is 2, or why the relationship is exact rather than approximate. Understanding the derivation clarifies what the equation means. It is not about converting mass into energy. It is about recognizing that mass is one form of energy. This distinction matters for interpreting physical processes correctly. Einstein did not discover that mass and energy are related by observing experiments. He derived the relationship by requiring that the laws of physics remain consistent across different reference frames. The speed of light squared appears because it is the proportionality constant needed to satisfy conservation laws in space-time. The equation is not an empirical fit. It is a structural requirement. Most explanations skip this and focus on the consequences, nuclear reactions and energy release. But the consequences follow from the mechanism, not the other way around. The equation works because space-time has a specific geometric structure. That structure determines how mass and energy must be related. This is what Einstein understood in 1905.